Hello everyone and welcome back to this lecture series on signal and signal and system. So if you missed the previous part of this video, you kindly check the playlist on signal and system, and then you'll find the links to all of those videos there. And if you are also yet to subscribe to the channel PA Academy, please just take out time right now to click on that subscribe button at the lower right of your screen. So just takes one or 2 seconds. Just click on that subscribe button. Alright, so thank you very much if you have just done that. So now we are going to be looking at the energy and power signal. So let's get started. So in terms of definition, if you have to define what energy signal is, we can say that energy signal, a signal is said to be an energy signal if and only if the total energy is equals to a finite value. So let's analyze that. So if and only if the total energy of that particular signal is equals to a finite value. So now let's look at it. So what's that trying to say? That means our E, it actually has a formula. So that means if you calculate the total energy of that signal using this is the formula, integral of minus infinity to infinity of magnitude of x of t square dt. So this is the formula. So if at the end of this is giving you a finite value, then we can conclude that that signal is an energy signal. And when we talk about it being an finite value, so that means you can say, so you can use this expression, 0 is less than E and less than infinity. So what it means is that the value we are going to be getting for our energy, the value will be greater than 0 and less than infinity. So that means there is a value. We can't just assume there is a number that continues till infinity. Exactly. So what we are having here, that it must give us a finite value. So this is the expression for it also. So that our energy, the value must be greater than 0 and less than infinity. And when this is followed, and when this happens, that means we are going to be having a finite value. And when we have a finite value, after applying those formula to that signal, we can conclude that it's an energy signal. So it's also important to mention that our E cannot be negative. Exactly. So that the energy signal cannot be negative. So if you do your calculation and at the end of the day you are getting a negative value, then you should know that it's not an energy signal, or probably there's a mistake. Exactly. So even if you look at it from here, we have this expression. I've made you know that the value is always greater than 0. Exactly. So this is 0 is less than E. So it's same thing as saying that E is greater than 0. So it can't be negative. So this is it on an energy signal. Before the end of this video, you are still going to look at an example under the energy signal, but just take note of this. So briefly, let's also talk about power signal. So if you talk about power signal, so let me just, so for power signal, you can say a signal is said to be a power signal if the average power P is finite. Exactly. If the average power P is finite. So for this also, we can also write it like this. So you also have to take note of this, that so if you have to compare maybe you have just one signal and then you are comparing it between the power and energy signal. Exactly. So you might have a question and it's okay, check if this signal is a power signal or an energy signal. Exactly. So if you, in that case, so you have to take note of this, that now when the power is finite, then the energy is equals to infinity. Exactly. This, just take note of this. It will make more sense if you're answering just one signal and then you are looking at it from the angle of being a power signal and an energy signal. So once you have a signal like that, and when you calculate the average power. When you calculate the average power and then you are getting a finite value, so and then you are also asked that you should also calculate the energy signal, the energy signal, yes, of that same signal. Just know that you are going to be having infinity as your answer, so you might not need to just go through the calculations again. So we can also write this as for power signal, that is 0 is less than p and then less than infinity. Exactly. All right, so let's continue. And then for power, now when we for energy signal we have this, right? So now for power signal, so the average power is giving us, that's, let's give it as p is equals to the limit as t approaches infinity of 1 over t, which is period, then the integral from minus t over 2 to t over 2 of x squared t dt. So what we have there, so if you had to calculate for the average power, so this is the expression or the formula that we are going to use. So don't worry, we are still going to use, and I'm looking into one example so that we can have a better understanding of some of those things. Alright, so let me add some random things that you might need to know as relates to power and energy signal before we look at some examples. So like I said before, so just if our E is equal to a finite value, then we can just conclude that our P is equals to 0. Exactly. So if you look at a particular signal and then when you calculate the energy of that signal, you are getting a finite value. Exactly. So you can just conclude that for that same signal, then the power is going to be 0. Exactly. So then another thing that you also need to take notes is that time reversal has no effect on the total energy. So that's energy there. So what we are saying here is, if you have a signal x of t and the energy is E, and then the time reversal of that signal, which is x of minus t, you are still going to get the same energy for it. Exactly. Okay. Right. So let me just share with you this. Okay, how many do I have here? So property of energy signal. So let me just write. Let me also just note this. So property of energy signal. So just in case you might be asked or you want to write something on this. So energy signal, let me just indicate that with ES, that energy signal. So they are absolutely integratable signal. So energy signal is absolutely integratable signal. So just like we had it earlier, so the integral of minus infinity to infinity of the absolute value, that's the positive value of x of t dt. So don't forget what this means. So that means if we are having a negative value, it just becomes positive. So equals to a finite value. So you can also have this. It says the total energy of a signal is always equal. Okay, is always equal to the area under the x of t square graph. Okay, all right, so let me just stop at those two. Okay, so that's for property of energy signal. So let me just write one property of power signal. So let's just say properties of power signal. Just a minute. Okay, so number one. So periodic signal are power signal, but power signals are not all periodic. Exactly. So just take note of this. So these are just a few properties. You might just need to take note of those, and then every other thing that has been said under power and energy signal. So now what I want to do now is let's just pick one example, and then we're going to use some of those formulas that I wrote earlier. So let's take a look at this example under energy signal. So the question says the signal x of t express okay, hold on. So the question said the signal x of t, which is what we are having here, expressed in the equation below. So this is the equation here, what we are having here. Exactly, is the equation they are talking about. With the figure, and now for this equation, this is the figure. Exactly, so this is the graphical form of it. It's an example of the energy signal. So we are going to use applying the energy signal formula to look for the total energy of this particular signal. Exactly. Now let's just analyze this. We have x of t, and then we have this equation. So from 0 to 1, you can see it here, from 0 to 1, we are given that the value is t. Exactly. Then from 1 to 2, you can see that means 1 is less than t, and t is less than or equals to 2. So then from 1 again to 2, we are giving the x of t to be 1. So I mixed something here, so there should be x of t here. So exactly. So if you look at it closely, you see that what we are having here is what we are having here. I hope you might just need to look at it closely so that you can understand how you can pick some of those. So how you can interpret if you have something like this. Just a minute, let me take this off. So you might just need to take a look at it very close so that once you have something like this, you know how to bring it to this. Exactly, it will help you in the course of this when you're looking at signal and system. All right, so now let's go ahead and solve this question using energy signal. But before we continue, I need to just make something clear here. So let's go back to where we look at energy signal. Okay, all right, so this formula that I have here, they are actually of two types. So we also have E can also be equals to the integral of from minus infinity to infinity of x squared t dt. So this that we are having here. So you use this when you want to calculate the total energy of a continuous time signal. Exactly. So when you want to calculate the energy of continuous time signal, CTS. Exactly. And then for this, so when you are looking at the complex value signal, complex valued signal. Exactly. So that is when you are going to use this. But if it's just a CTS signal, we are going to be using this. So this is the one that we are going to be applying in the example that I want to look at. So don't worry, we are still going to look at an example where we are going to be making use of this. All right, so now let's go back to this. Okay. All right. So since we already have the question now, let's bring in the formula. So we have E. So let me just put it here. So we have our E. So I'm just writing out the formula is equals to the integral of minus infinity to infinity of s squared t over the t. So let me just mention this. So once you see this minus infinity to infinity, although it's integration, that doesn't mean we are going to be having a negative value here and then a negative value here and a positive value here. So what this is just saying is that you are going to pick it from the lower value will be down and then the higher value will be up. So it's not that you are going to be having a negative value here. Exactly. So you can just, that's just integration. But I just need to mention it so you don't, so that one or two person watching the video might not be confused. All right. So what we are having here, we will now have it as the integral. So we are going to pick this first. This one I've just marked is what's going on from here. That's from 0 to 1. Exactly. So we are going to be having the integral from 0 to 1 of t square, because you can see it here, of t square dt. Then we continue plus the integral. Now for this second one. For the second one now is from here to here. Exactly. So for this now is going to be from 1 to 2. Exactly, from the least value to the higher value, and then we are having it to be 1. So it's going to be 1. Can let 1 square is same thing as 1. So let me just put it dt. All right. So let's go ahead and simplify this using integration. So if you have to do this t square, we are going to be having it as remember the square, we are going to be adding 1 to it, and then whatever we get, we are going to divide it by that value. So we are going to be having t, that's raised to power 2 plus 1. That will be t raised to power 3 divided by 3. So what I'm just doing here is just integration. Then from 0 to 1. So we've done this plus. Now for 1 square. So this 1 square is the same thing as 1. So we can just as well, okay, let's just leave it there. We can decide to leave it as 1 anyway, but let's just leave it as that 1 square there. So if you should integrate 1, exactly, don't forget if you have to integrate 1, so for the things we are doing with respect of dt, which is t, so you are going to be giving us t. Exactly, so if you should integrate 1, it will give us t. So with that now, what we are going to be having here is t from 1 to 2. Exactly, so now let's simplify this. So we are going to be having one raised to, so this t now we are going to replace it with 1. So we are going to be having 1 raised to power 3 over 3 minus 0 raised to power 3 over 3 plus. So what we are having here is we are going to be having 2 minus 1. This is just integration, so don't get confused. So let me just go through it. So this t raised to power 3 over 3, and then this is the range from 0 to 1. So what we are going to do is we are going to replace t with 1 and then subtract it when we replace t with 0, everything here. So that's what is happening here. So we've replaced t with 1, exactly, and then we are subtracting it again when we replace t with 0. So the same thing happened here. We've replaced t with 2, subtract it when we replace t with 1. Exactly. All right, so let's continue. All right, so that will just be 1 over 3, just to make sure that, so that will be all of this will just give us 1 over 3, and then plus, now 2 minus 1, that is 1, and when we do this, we are going to be having 4 over 3, exactly. So the energy of this particular signal, so we can just conclude that our E is 4 over 3. So with that now, I think I'll have to stop here and continue in another video. So I hope you find value in all of this that we looked at in this particular one on energy and power signal. So if you have any question or any comment, do leave them in the comment section below, and then I'll attend to it. So thank you very much. If you find value again, please give it a thumbs up. Don't forget to like and subscribe. And then I'll see you all in the next one.